Alright, the last thing we're going to do in this lesson, now that we understand how to graph exponential functions and what they look like, is we're going to compare them versus a linear function. So if you recall back to linear, linear is typically in the form y equals mx plus b. Now this is not the only form of a line, there's point, slope, and standard, but this is of course the most common. And it has a, remember that it always changes by a common difference or a constant rate. Okay, so per unit interval. And it's going to be a linear function. So again, remember that common difference is your slope. That's all this means, is it's going to have a constant rate of change, a slope. And we can easily see this in the graph if we find 2 points. Any 2 points on here, we're going to find that it has the same slope, up 2 over 1, up 2 over 1, and so on. Now, an exponential function takes the form of y, or f of x, equals a times b to the x power. And it changes by a common ratio over an equal interval. So common ratio means what you're multiplying by. Okay, so what that means is if you look at this graph at any 2 points, they're not going to be increasing at the same adding or subtracting, but what is going to happen is you're going to find that they're multiplying the same. So to get from here to here, from here to here, you're multiplying by the same factor, which in this case is 2, because if you start at 1, to go to 2, you multiply by 2. To go to 4, you multiply by 2. So it's a little bit different. So slope is going to be adding or subtracting. Okay. Common ratio is going to be multiplying or dividing. Okay, so multiplying by the reciprocal is what division is. So down here, we're going to look at some tables and some scenarios. So at number 4, we have a table. So the first thing is we have to make sure things are in order. So meaning x's should be in order. So -2, -1, 0, 1, 2, no gaps. That makes things much easier. So we notice our x's are increasing by 1. That's our unit interval. So up here where it says per unit interval, okay, over equal intervals, that means the x's have to be the same interval apart. So if it's adding 1 every time, that's the same interval. Or adding 2 every time, or 3, and so on. They can't be adding 1 here and adding 3 here if you're trying to find an exponential function, okay? So then we're going to look at our y values. So how are we getting from 3 to 9, 9 to 27, 27 to 81, and 81 to 243. Well, we can clearly see we're not adding the same number because we're kind of starting small and getting big really fast, which means we're most likely multiplying. So to go from 3 to 9, we have to multiply by 3. So 9 to 27 times 3. And it looks like it's going to continue with this pattern the whole way through. So because we are multiplying by 3 every time, that means this is an exponential function. Okay, so since it is exponential, that means we're going to be using the formula y equals a times b to the x power. So when we write our function, we're going to have y equals, our a is our starting amount. So this is basically our y-intercept. Okay, so looking at our table here, our y-intercept is where x is 0. So 0, 27, which means our a is going to be 27. Times our b is our ratio. So this is our common ratio, what we're multiplying by, which means in this case we're multiplying by 3, and then we raise it to the x power. So this would be our function. Start at 27, our 0, times 3 every time to get to the next value. Okay, so let's look at number 5. So first thing we want to make sure is that we're going over equal intervals. So x is adding 1, adding 1, adding 1, adding 1. So the good news is we have equal intervals for our x values. So now we're going to look at our y values and figure out what we're doing to go to each number. Now notice there's not a big jump here. So it could be exponential, but my guess is it's probably linear. So let's check. If we go from -2 to 0, we're going to add 2. 0 to 2 is add 2. And it looks like it's going to continue to add 2, which means this is going to be a linear function. And if you'll recall, linear function is y equals mx plus b. So m, of course, is our slope. and b, of course, is our y-intercept. So when we write our function here, we're going to have y equals, well, our slope is add 2, so that's going to be 2x. And then our y-intercept is going to be 0, 2. So that means we're going to be adding 2 for our y-intercept. And that would be our function. Okay, so I want you to try number 6 on your own. When you're ready, pause the video now, and when you're ready, turn it back on. Alright, so hopefully you figured out this was an exponential function. It is multiplying by 4 each time, and it's starting at the value -1 because that's the y-intercept. So you might have written it as y equals -1 times 4 to the x, and that is perfectly acceptable. However, you may sometimes see this as y equals -4 to the x without parentheses. Both of these is acceptable, and if you recall, that's because the x does not get distributed to the -1 here. So sometimes you'll see that people or mathematicians don't write the -1, they just write negative and then 4x. But if you write the -1, that is 100% correct. Alright, so let's look at number 7. It says a library has 8,000 books and is adding 500 more books each year. So since we are adding 500 books each year, that's over, here's our unit interval, each year is our interval, and we're adding. Anytime you're adding, this is going to be a linear function. So linear, which means we're starting with 8,000 books, and we're adding 500, which means 500 is our slope. So that's going to be our m. So y equals 500x, and 8,000 is going to be our y-intercept. That's where we're going to be starting at. So this is our function for number 7. Right, so number 8 says a bank account starts with $10. So that sounds like it's going to be our y-intercept. That's what we're starting with. And every month the amount of money is tripled. So tripled means to multiply by 3. So multiplying by 3 is going to be an exponential function. So that means we're going to write exponential. And we're going to start with y equals. Now remember, in an exponential function, your y-intercept comes first. So we're starting with $10. And every month we're going to multiply it. So every month is going to be our unit interval. We're going to multiply by 3. So 3 to the x. X represents the number of months. And that would be our function. Okay, so go ahead and try number 9 for me, and when you're ready, turn on the video. So hopefully you knew this was an exponential function because the number of vowels is being halved. Halved means multiply by a half. So 20,000 times a half to the x power. Now one thing I should recall to your attention is make sure you have y equals, make sure you have your x, and make sure 1/2 is in parentheses. Anytime you have a fraction, you have to put parentheses around it. Now you could put 0.5 and that would be fine. If you had y equals 20,000 times 0.5 to the x, you wouldn't need the parentheses. You still might want to put them just because it looks a little messy with all the decimals. But if it's a fraction, you must put the parentheses. Okay, so this is the end of your notes. If you will make sure and stick this in the notes section of your notebook. And if you have any questions, make a note and ask me tomorrow about it.